When it comes to building project cars, there's something incredibly satisfying about a sleeper. Something that from the outside doesn't really make people look twice, but when that car can run an 8.7 at 156 mile an hour on the quarter, blowing away every production supercar ever made, then there's something incredibly special about that sort of a car. And we're here with Christian to talk about his KE36 Toyota Corolla, a car that can run those exact numbers. Now, for a start, Christian, clearly the original 3K that came out in this car probably not going to get you anywhere near the 8-second range. So can you tell us what you've got powering this wagon?
So this time round we've got a 1JZ VVTi. We had a non-VVTi in it originally, but no one over here was really pushing the VVTi, so we decided to see what we could make out of it.
Okay, so the VVTi, the variable valve timing, so that allows the intake cam timing to be moved while the engine's running. I want to come back and focus on that, but first of all, just getting down to the elephant in the room, 1JZ versus the 2JZ. Most people are going to go straight for the top shelf, 2JZ, more capacity. What drove you to go with the 2.5 litre 1J?
We've had 1Js for probably nearly 20 years now that we've been playing with, so originally we bought them because they were cheaper, more available. They'll make the power we need, so there's no point in us going to the bigger engine. And legally for Australia, we can only put the 2.5 litre in this car, not the 3 litre. So
that's peculiar to Australia's rules for certification or modification for cars. You've got I believe it's a capacity to car weight.
Yep, that's correct. So this one makes it by about 8 kilos to have the 2.5 litre. So.
Now, before we get people up in arms out there on the internet, clearly if you're building a drag car with a JZ powered engine and you're aiming for 5s, then yes, the extra capacity of the 2JZ and then probably a stroker kit on top of that is going to be pretty essential. But when you're talking about predominantly a street driven car that's drag raced as well, the 1JZ, you're still making plenty of power. How much power is it making?
So this one makes just over 800 to the wheels through a Toyota A340 gearbox still. So it's limited only by injector size really. So.
All right, so it's a bit to unpack there. First of all, getting down to that power level, what have you needed to do in order to support 800 wheel horsepower? We're going to assume based on your dyno drivetrain losses, that's going to be north of 900 flywheel. So what do you need to do to a 1JZ to support that power and be reliable?
So this has got one of our 900 horsepower engine packages. It's just basically spill rods, CP pistons. We've got a set of Brian Crower cams and springs. Still factory main caps. That's about where we limit the engines to reliably with the factory caps.
So both the 1J and the 2JZ are the cast caps, the factory caps that hold the crankshaft into the block. That's a known failure point. So that's sort of above that area, you really need to go to billet caps?
Yeah, correct. So 1J you may be able to get away with a bit more power beforehand with a smaller capacity. I don't know, less rotating weight maybe. But around the 900 horsepower is a good safe spot to put them in.
So essentially in that bottom end, there's not a lot of particularly special componentry in there. You're not talking about aftermarket billet crankshafts, and the head again, nothing particularly special there. Do you have any problems or anything special you need to do with sealing the cylinder head onto the block at that sort of power level?
Cylinder head to block is fine. Factory head gasket, this has just got ARP in your 8740 material. We've run up to 56 pounds of boost in a 1J with factory head gaskets, so if you keep the cylinder pressures down, the head will stay on.
And what sort of boost pressure are you running for that 800 wheel horsepower?
This one made 810 on 36 pound.
So really, realistically not pushing it particularly hard?
Yeah, we wanted it to be reliable, so far we've done probably 10,000 Ks in it, so we'll do just over 2,000 this weekend in it, so.
I wanted to focus on that because it isn't just a show car and it's not just a drag car. This is genuinely a daily driven street car.
Yeah, correct. We use it most days for work. I've got another van as well that we use, but it's probably 50% of my daily driving time's done in this car. So.
Now, just coming back, I said I wanted to focus on that VVTi cylinder head. So you originally ran this with the non-VVTi head. So fixed cam timing, and then you've gone to the VVTi cylinder head, which allows that intake cam to be controlled and moved while the engine's running to optimise the cam timing versus throttle position, manifold pressure and engine RPM. So what sort of differences do you realistically see? How much of an advantage is that variable valve timing? Because we know a lot of people, when they build a race motor making high horsepower, they'll go to an aggressive cam which requires the VVT system to be locked out anyway. You've kept it, so yeah, give us the advantages there.
So mainly street car to start with, nice low down power. It actually makes it better on fuel, obviously. And we went to a slightly bigger turbo. We used to have a 6870 with the non-VVTi. We went to a 7275, so we wanted a bit more response, and it worked out about the same response having the VVTi with the bigger turbo.
So it allows you to go to a bigger turbo without losing that bottom end and that spool.
Correct, so it's still streetable. It's to the point where you don't want much more, it's going to be a lag monster. So
Now, that brings me to the turbo. Nice segue in there, because I was just going to ask you what the turbo was. You've covered that off. So with that turbo, the VVTi, and also the fact you've got a 2.5 litre engine there, what sort of RPM are you seeing full boost achieved?
I think full boost would be about 5.5. It starts making 10-15 pound by probably 4.5 to 5. So.
And you rev it through to what RPM?
Makes power to about 8.7, 8.8. I think we rev it to just over 9 just for mile an hour at the track. We can only get a 3.5 diff ratio in a Hilux diff, so.
Right, so before we get on to the rest of the drivetrain, because that's also quite unique what you've done with this car, can you just give us a rundown on the electronics package you've got controlling the engine?
Yep, so it's got a Haltech Elite 2500T in it. It's got the wideband, it's got the new EGT box in it. Apart from that, it's got Bosch injectors, 1650cc and two 044 pumps.
All right, so let's just go back to that. You've got the 2500T Haltech ECU, so that's in control of everything in there. You mentioned you've got the wideband, so can I assume there you're running the cam-based Haltech wideband?
Yes, correct. The newer version, yep.
All right, so that transfers all of the wideband air-fuel ratio data into the Haltech ECU via CAN. One of my personal favourites, because it retains the integrity of that data, unlike what we can see problems with an analog voltage voltage-based wideband controller, where we can see ground offsets affecting the accuracy of that data. Now, once you've got that information in there, there's a variety of ways you can use that information in the Haltech. Are you using any closed-loop air-fuel ratio control strategies, or are you just using it for tuning purposes?
No, it's closed loop all the time, so it's road and track, so it's always trimming. So we've done a lot of Ks in it now, so the map in the car is pretty good.
It's one of the things I really like with the cam-based controller as well, because in the past with the older style controllers, there's no diagnostic information going through to the ECU, so if the sensor fails, the ECU doesn't necessarily know. It can be problematic if you are running wideband control, so that cam-based controller lets the ECU know exactly what's going on. So on top of that, you're also running those 1650cc Bosch injectors, and is it safe to assume there, given the power and the size of the injectors, you're running on E85 fuel?
Yep, E85 fuel, and 810 horsepower is about 98% duty cycle, so
there's really nothing left in there. Would you go to a bigger set of injectors, or you're just happy where that power is?
we basically put them in to limit the power and stop us getting out of control, so it's too easy to turn the up button. At 40 pounds of boost, I think injectors are 110%, so fuel just keeps up, but obviously it's well past what it's capable of.
And are you running flex fuel here, or is this just dedicated E85?
It's dedicated E85. We've got a flex sensor in the car, but we've never had the need to set it up.
Now, in terms of the boost control on this, I'm going to guess that getting all of that power, 800 horsepower to the ground off the start line is probably going to be pretty tricky. So are you using any boost control strategies versus either road speed or gear?
Yep, for like our roll racing events or the Flying 500 here, we have road speed, whereas at the drag strip we can pretty much put it in as fast as it'll make it.
All right, so let's get on to the drivetrain, because again, this is somewhat unique. I haven't seen this before. Most people go to something like a Power Glide if they're going auto. You're stuck with the auto, but you wanted to keep everything Toyota. So tell us what you've got in there.
So we retain the Toyota A340 4-speed auto. It's built by one of our friends in town, Gilroy's Race Transmissions. So we've played with them a lot over the years. This is the fastest we've gone so far, but we're building another one and want to go closer to 8.0 with a Toyota box.
So is there some big limitations within that gearbox that need upgrading to support that sort of power level?
Yeah, we've got some bits coming from the US One of the places over there makes a bit of stuff, but this is essentially still a fairly basic box. I think they retail them for around $4,000 for the gearbox, so something that can run 8 seconds, it's a cheap gearbox.
Yeah, that's definitely pretty cost effective. So moving back, can you tell us about the rear end in the car? What are you running there?
So rear end's just a factory RN20 Hilux diff. It's got a set of traction arms and a aftermarket sway bar. Other than that, it's all factory Corolla.
So you're talking LSD in that, or is it a full spool?
It's got an LSD in it, yeah.
So again, keeping it somewhat streetable.
Yeah, street car.
Now with that transmission, again, getting an automatic transmission equipped car with a large turbo off the line can be a bit tricky, and the go-to we usually see is people using a trans brake, where essentially first gear and reverse gear are locked in. You can floor the throttle and allow the engine to produce boost and then release reverse when the tree comes down. You're not doing that. Tell us about your launch strategy.
Yeah, well, launch strategy, our PB was actually done without nitrous. We've run a 134 to the 60. The bigger turbo probably put us about 100 RPM off optimum launch, so we've got around a 35 horsepower shot on the car to get it out of the hole.
So you're only using that just off the line?
Just off the line, as we got no more injector left to spray at the whole track. So.
But you're also just launching solely off the foot brake?
Foot brake and handbrake, yeah. We leave around 4,500 RPM, so.
So it's sort of able to make reasonable amount of boost there, just that shot of nitrous. Are you using as you leave the line, or is that just to bring it up on boost while you're on the foot brake and the handbrake?
We use it just before the two-step and then just after. So it sprays about half a second after the brakes let go as well.
So on that basis, would you see actually any advantage if you were to go to a trans brake on this, or you think it's pretty optimal just with the technique you're using?
You can't trans brake the A340, but a power glide gearbox with a trans brake, the car would go slightly faster, but wouldn't keep it all Toyota.
Fair enough, I understand. The car's also well known for bringing the front wheels well off the ground. So can you just tell us about controlling that? I mean, I see you've got no wheelie bars on the back of the car. Is this just a dedicated decision? You want to keep it without wheelie bars and control that all manually? You like getting those front wheels as high as you can? Because obviously there's a danger of damaging componentry when it does come back down. Give us some insight into that.
Jamboree we just did, we kind of just kept putting nitrous in to have some fun. The 35 horsepower shot still picks the wheels up probably a foot, so then we put a 50 shot in it and picked them up probably 3 foot, and then we put a 75 in it and it put it on the bumper. So we did do that on purpose, and we've done it now, so we'll stick to around the 35 shot, and that should get us hopefully eventually into maybe 12960 or something like that.
All right, look, Christian, it's been great to get some insight into the car, and it's certainly a car that is going to appeal to a lot of our viewers there, with the fact that it is something that they can aspire to. It's a sleeper, but it still runs 8.7s, so certainly no slouch, and we wish you all the best for the rest of the weekend here at World Time Attack. Thanks.
No worries, thank you very much.
If you liked that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.